Okay, so this is the final 3 parts of accentuate the negative 1.4. So Part D gives you this table and asks you to find the missing part for each chip problem and to write a number sentence for each chip problem. In Part D, again, hopefully you are using the book Accentuate the Negative 1.4 to follow along with the activity. If you are recording your answers online in a Google Doc, you can go ahead and turn that in Google Classroom. That's awesome. If you're doing it on paper and just using the videos to help you out, turning in a set of papers stapled in together when it's due is perfectly fine. And then, of course, if you are doing it on paper at home and you want to submit either pictures or a video, that is acceptable as well, just as long as you're doing the work along with me, in addition to watching the video. So here we've got Part D. Part D says we're going to start with 3 red chips. That is a -3. And we're going to add 5 black chips. So -3 plus 5 black chips. If you imagine there are 5 black chips in addition to those 3 red chips, so 3 of them would cancel out and leave us with 2 black chips, or a +2. As a number sentence, it would look like this. -3 plus a +5, or just +5, would equal +2. All right, so that's the answer for number 1. If we take a look at number 2, we have 2 red chips and 1 black chip. So these 2 cancel each other out, and we're left with a -1. So that's a -1, and we're going to subtract a -3. So notice we have 2 minus signs or subtraction signs, or subtraction and a negative sign here. So those cancel out if we want to think about that mentally, and we're adding 3 black chips to this. So subtracting a negative is the same as adding a positive, because if we have this -1 and we take away 3 red chips, that means we're going to take away these 2 red chips here, which will leave us just 1 black chip, and then we'll have to add a black and red pair to take away another red chip, which would then leave us with 2 black chips on the table. So we have a +2. If we want to visualize that, I can do that using this slide. And let's go ahead and clear annotations here. All right, so in our problem, we have 2 red and 1 black. So we have 2 red and 1 black, right? So this is a -1. And if we're going to take away 3 red chips, that means we have to add in another pair here so that we have 3 red chips to take away, right? This doesn't change the fact that this whole board is still a -1. And if we look at here, that's what we have here is a -1, right? This black chip cancels out this red chip, so we have -1. So this is also -1. But in this scenario, we can actually highlight and remove 3 red chips. So if we take away 3 red chips, or we take away 3 negatives, we will end up with a +2. All right? Taking away 3 negatives is making it 3 more positive. Is another way of looking at it. So the number sentence is -1 minus a -3 equals a +2. We're going to definitely practice this a lot in this unit. So here we've got -6. The way we end up at -2 is to take away 4 of these red chips. So we're going to subtract a -4. We're going to make it less negative. Another way of looking at that is we're going to make it more positive. So -6, and we make it 4 less negative, and now it's -2. This is the number sentence for that. So we're going to take -6, which is really low on the number line, and we're going to make it less negative, so we're going to push it towards the positive numbers by 4 units, which will leave us at -2, closer to 0. -2 is much closer to 0, much closer to being positive than -6 is. So taking away negatives makes something more positive. Number 4, where we start off in order to take away 3 red chips and end up at 4 black chips, ending up at 4 positive, is we would have to end up, or we would have to start, at 1. So if we start at 1, I can show that here. If we start at 1, the only way that we can take away 3 negatives, subtract 3 negatives here, and end up at +4 is if we were to start at +1. And we would have to start at +1 with a whole bunch of positive and negative pairs. Hold on, let me refresh what I'm doing here at the problem. So we're going to subtract 3 negatives. So we need to make sure we have 3 negatives to take away. So sorry about that. So somehow we need to end up at +4 by taking away 3 negatives. And the only way we can do that is if we're in this situation. So this is a +1 with 3 0 pairs. So a positive and a negative makes a 0 pair. And then if we take away or subtract 3 negatives, we will end up with 4 positives. So if we start off with a +1 and subtract 3 negatives or add 3 positives, same thing, we end up at a +4. This is the way of using the chip model to visualize adding and subtracting negative numbers. All right, so you can subtract 3. You can subtract a -3 from a positive number, and the only way to do that is to have those 0 pairs with the chip model. All right, we're going to learn that outside of the chip model for understanding. So on your daily use of negatives, when you subtract a negative, it's the same as adding a positive. You're making something less negative, so you're making it more positive. So if you imagine someone that's really grumpy, by taking away their grumpiness, you're making them a happier person. So subtracting negatives creates a positive. If you have something that floats being weighed down, so that has negative to it, underwater, and you take away that negative, that item that floats is going to head in the positive direction. So taking away negatives pushes something in the positive direction. All right, so now we're in part E. Part E, where it's given us number sentences and we have to fill in the missing value, and it's asking us to use the chipboard model to do that. So 3 positives could be 3 black minus 2 black would give us 1 black. So this is a basic 3 minus 2 equals 1. But thinking about it in chips, if we have 3 black chips minus 2 black chips, we have 1 black chip left over. All right. Number 2, we have 4 negatives, so 4 red chips, and we're going to take away 2 positive chips. Well, the only way to take away 2 positive chips would be to add those 0 pairs. But that ends up giving us 6 red chips left on the board. All right. So -4 minus 2 is -6. We're going in the negative direction. Number 3 is a little bit different. If we have 4 red chips and we take away 2 red chips, we're left with just 2 red chips. Again, subtracting a negative has made -4 more positive. So it has become closer to 0, which is positive territory. So for number 3, 4 red chips minus 2 red chips leaves us with 2 red chips. 4 minus -2 leaves us with -2, much closer to 0. So number 4, we start off with 7 black chips. Somehow we're going to add to the chipboard. We're going to add something, and we're going to end up with a smaller number. We're going to end up with +1 instead of +7. And the only way to do that is to add negatives. So we're going to add 6 red chips to end up with 1 black chip on the board. All right, that's number 4. Number 5, we're going to start off with 3 red chips, and we're going to subtract away 5 black chips, and those black chips don't exist, so we're going to have to add a bunch of negative 0 pairs. And when we do that and we take away the black chips that were associated with those 0 pairs, we end up with a lot more negatives. So -3 minus +5, we end up with 8 red chips on the board. So 3 minus 5, -3 minus 5 is -8. Number 6, and we're going to get outside of this model as we move forward through the chapter. So if this model feels confusing for you, again, I'm going to link in the assignment a link to use this model for yourself if drawing it out doesn't really work out, and you can kind of see everything that I'm showing you and working through with the chip model here. You could do that on your own. So number 6, the only way that we can subtract 2 negatives and end up at +6 is if we had started off with 4 black. So really, if I want to edit this to be more more accurate, I'm going to have 6 black with 2 red, right? 6 black with 2 red is -4. And when I subtract away those 2 red, I end up with 6 black. So really, I'm starting off with a -4 value. And the way I get that -4 value is with 6 black and 2 red. And then when I take away the 2 red, I end up with 6 black. We have to understand that 6 black with 2 red is a +4. 6 black with 2 red is a +4 because these 2 red cancel out 2 of these black. But this is how we end up with the 2 red that we're able to take away and be left with 6 black. So the number sentence here would be a +4 minus a -2, which is the same as adding a +2, will give us a +6. All right. And then we are at our final part, part F. Nadi has a chipboard with 4 red chips. She needs to subtract 2 black chips, but there are no black chips on the board. Nadi says it's impossible to subtract 2 black chips. There are none on the board. What can Nadi do to the chipboard to make sure that she has 2 black chips that she can subtract? What does she do? And then explain our reasoning. Nadi can add 2 black chips and 2 red chips to the board because that would be like adding 0. The 2 black chips and the 2 red chips would cancel each other out. With the new chips on the board, Nadi could then subtract the 2 black. That's it. That's all she needs to do. And we would see that she would end up with 6 red chips, which would be -6. All right. So this is understanding adding and subtracting positive and negative numbers using a chip model. So we're going to transition in the next part away, not the next part, in the next section, away from using the chip model and just using the algorithm, which is adding negatives makes things more negative, subtracting positives makes things more negative, adding positives makes things more positive, subtracting negatives makes things more positive, and we're going to see what that looks like on a number line instead of the chip model. All right, so thank you for watching. Again, I hope this helped, and looking forward to seeing all of my students turn in all of the work for Investigation 1.4.